Just like how we have measurements for measuring physical distance, like inches, centimeters, meters, feet, miles, kilometers, and more, we have measurements in computing. Computers measure almost everything from how much data we have in storage to how fast everything moves on a network or through the internet. In this video, we'll break down the most common units that you'll see in everyday computing. We'll be covering bits and bytes, kilobytes, megabytes, gigabytes, and terabytes. We'll be talking about CPU speed. We'll be talking about data throughput as well. So generally that refers to how fast our internet connection is or a local network connection. And then we'll be talking about data size versus bandwidth. Let's talk about bits, bytes, kilobytes, megabytes, gigabytes, and terabytes first. This is our data size. Normally when we talk about these, we're referring to data on our computer or our data on files. So for example, if we have a PDF file, it might be 2 megabytes. When we go to store that on our local computer, we need to have free at least 2 megabytes of storage in order to actually hold that file. Same thing with cloud storage. If we have something like Google Drive or Dropbox, we need available storage in order to accommodate that file and to be able to keep it there. Let's talk about bits first. So bits are our binary digit. We learned about these in the previous video, and they're our smallest unit of data, which represents either a 0 or a 1. Our bytes, remember, are 8 bits. So 8 bits make up 1 byte, and bytes are normally used to represent a single character. From here, we have kilobytes, or lowercase k, uppercase b. This is 1,000 bytes. So 1,000 bytes, not 1,000 bits. Same thing with megabytes, or uppercase m, uppercase b. This is 1,000 kilobytes. From there, we have gigabytes, or uppercase g, uppercase b. That's 1,000 megabytes. From here, we have terabytes, or uppercase T, uppercase B, and that's 1,000 gigabytes. The main thing you need to understand are these units in definitions, and you can understand their values very, very simple, only from the left side of this graph. Now, you can look at the value. So for example, if you want to, you can pause the video and look at each of these to understand, for example, megabytes. That's 1,000 bytes or 1,000 kilobytes. But things start to become a little bit more complex when you start breaking down how much each one is in terms of the actual byte amount. That's why I recommend you mainly focus on the unit and definition here on the left, because once you get that, everything else will fall into place. Here's some various storage devices where that actually comes into play. So when we have, say, a hard drive or HDD, we normally will have them between around 200 or so gigabytes all the way up to 10 terabytes or even more. Same thing with solid state drives. We'll have those in terms of gigabytes or terabytes. Flash drives, those are normally in terms of gigabytes. SD cards, we normally have storage amounts of gigabytes as well. So all these different types of storage devices, particularly in modern day storage devices, are normally measured in gigabytes and terabytes. But keep in mind, the files that we have can be of any size. They could be in megabytes, they could be in gigabytes, they could be in terabytes. For the most part, you'll see when you do most of your downloads, they'll come in as megabytes or gigabytes. In fact, if you pause this video now and go out to your downloads folder, you can look at all of your recent downloads, say the past 20 or 30 files, and look at the sizes, and more than likely there's some range of megabyte, probably between 1 to 500 megabytes. Next up is our CPU speed, and this indicates how many processing cycles our CPU, or central processing unit, can perform every second. So 1 gigahertz is equal to 1 billion cycles per second. The more gigahertz speed that your CPU can operate at generally means that the faster your CPU is going to be, and generally your system as well. In terms of primary use, it helps compare processors, and it just helps you understand how your CPU or your processor is actually going to perform in the real world. Next up is data throughput, and data throughput is pretty simple. It just measures how fast data is transferred from one place to another. For example, if we create a YouTube video, we have that YouTube video on our laptop, we go to YouTube, we upload that video, that's where our data throughput is going to matter, because now we're moving data from one place to another. In terms of data throughput, we normally talk about this in terms of transferring a file over the internet. So we don't really talk about this as much when we're transferring local data on our laptop. For the most part, we talk about this when we're transferring data through the internet, but we can still refer to it when we're transferring local files. For example, if we're transferring something through our laptop to a USB drive we have plugged in, we can still use the term data throughput. It's just measuring how fast we're able to actually transfer files and how fast our speed actually is. Our internet speed is normally measured in uppercase M, lowercase bps. Again, uppercase M, bps here like it is on screen. This stands for megabits per second. This measures the data transfer speed in bits, and it's used for network and internet speeds. So again, if we're going out, we're uploading something on the internet, we're downloading something, that is the area we use megabits, or uppercase M, lowercase bps. We use this primarily for transferring data over the internet or on a network. For local data transfer, for example, going back to our example earlier, we're transferring data from a computer or a laptop to a flash drive we have plugged in on our computer. Then we're using uppercase M, uppercase B, PS, or megabytes per second. So pause the video now if you haven't already taken a note. Make sure you understand the difference between M, lowercase bps, and M, uppercase B, PS, because those are both two different concepts, and those are something that commonly trips people up that you need to understand. Going forward, megabytes per second, it transfers data speed in terms of bytes, and this is mainly used for local file transfer and for storage performance locally. So 8 Mbps, or 8 megabits per second, equals 1 megabyte per second. The primary difference is that 8 megabits per second equals 1 megabyte per second. So keep those in mind. Megabits, or uppercase M, lowercase b. PS, we normally use for network and internet. M, uppercase B, PS, we normally use for local storage. Next here is an internet speed test. You can go online and look up internet speed test on Google and find an internet speed test just like this one. So that's what I did. Went online, found this one, and then I went forward and tested my internet speed by pressing the go button. Once I did this, was the results. So it ran this test for around 20 to 30 seconds, no longer than a minute. And it came back with this as the Mbps as this was actually running. So you can see here, this was my download speed as it was running. It tends to fluctuate up and down, but when you get to the very end, it gives you a conclusive result of your internet speed. So here you can see this was our internet speed. This was our download and upload. So download is how fast we're able to download things. Upload is how fast we're able to upload things. You can see here, this is measured in uppercase M, lowercase bps, and the same thing with upload, because we're referring to the internet or network. This is uppercase M, lowercase b. Let's move into data size and bandwidth now. So data size refers to how much data a file contains. Now let's cover the concept of bandwidth. And many people confuse bandwidth and throughput. We've already covered throughput, so let's talk about bandwidth. Bandwidth is essentially the maximum limit of how fast we can transfer data or information. Throughput, on the other hand, is how fast we're actually transferring data. So bandwidth is like your cap. Think of data almost from the perspective of a NASCAR driver or someone driving an extremely fast car, right? So our throughput is what we're able to actually do. If we're out driving, we can't go 150 miles an hour. While the car might be capable of doing that, the actual realities of the limitation, the speed limit, how traffic is, the weather conditions, there's so many different variables. And the same thing goes with computers and with networks in general and with the internet. Our throughput is how much we're actually doing, how fast things are actually able to go with current conditions. Our bandwidth is our ceiling, especially when we're talking about internet speed. So for example, your internet provider might advertise a speed of 1 gigabit per second, right? But in reality, are you going to be able to hit that? Probably not. And that's why oftentimes we pay for a plan and we're not receiving as fast of a speed as advertised, because conditions would need to be perfect in order for our throughput, or our real speed, to actually hit the speed of bandwidth, or our maximum cap of what we can actually do. Many people get confused about these two, but they're very, very simple concepts once you break them down. And bandwidth is really the upper limitation, or the actual ceiling of the speed that we can hit. It's not the actual speed that we can hit. It's if all conditions are perfect, if every single thing lines up, then that's the maximum that we can go. But for the most part, depending on your networking equipment, your laptop, how close or far you are from your Wi-Fi, how congested your internet service provider is. So if a ton of people are streaming, if the internet service provider is having a huge load from other customers, that can affect everything as far as your throughput goes.